Dear colleagues, let us talk about the construction industry and its climate-dependent problems. Let me continue introducing my colleague Tetiana TKACHENKO, Doctor Habilitatus, Professor, Head of the Department of Environmental Protection Technologies and Labor Safety in Kyiv National University of Construction and Architecture. She is a well-known scientist and researcher of green construction, green structures, and indoor greening, especially their positive influence on the indoor and outdoor environment, climate change, plant ecology, land reclamation, waste management, etc. She published near to 400 works. Let us start from a brief history of the construction industry in the context of climate change. We can't be proud of having created the construction industry on the earth or having construction production, weaving and green structures. Even before the appearance of man, nesting birds knew how to build from natural materials, beavers mastered hydraulic engineering, and paper wasps built from an artificially created material, paper. Tailor birds have learned to sew together living leaves in which to build a nest of small twigs and down. The resulting green roof and walls, in addition to providing protection from precipitation and sunlight, serve as a natural air conditioner through the effect of evaporative cooling due to transpiration. The construction was as environmentally friendly as possible and had a closed cycle. Waste was recycled by reducing agents into minerals, which were then consumed by plants. At the beginning of human construction, dating back 2 million years, simple shelters were made of wood, clay, stone, and bone, and other natural materials. Such housing is environmentally friendly. There is a reasonable assumption that it was in prehistoric times the first turf covering of house appeared. Around 3000 BC, large-scale stone construction began, and construction tools, mechanisms, and technologies appeared, some of which remain unknown. Today, the Parthenon in Athens is known, the Roman Colosseum partially dismantled for the construction of other structures, an example of ancient reuse of building materials, etc. To this day, the principle of achieving the unique acoustic characteristic of the ancient Greek open-air theater in Epidaurus remain unclear. At the temple clinic of Asclepius, where whispers from the scene can be heard without amplification in the last rows. It's only known that filling the aisles with people stopped the propagation of sound. The Middle Ages were marked by the mass construction of large castles, estates, and palaces, with significant impact of ecosystems but with little impact on climate change. The main source of heating was biomass that had recently accumulated carbon from the atmosphere. In essence, heating and production processes resulted in the return of newly sequestrated carbon to the atmosphere, maintaining the balance for a decade. At the same time, with the conquest of steam, the development of mining and metallurgy, the share of technologies that create harmful emissions, and an excess of greenhouse gases increased. In the 20th century, this process became avalanche-like. Due to metropolization, the volume of construction is growing rapidly, which turned the construction industry into one of the main sources of atmospheric pollution and greenhouse gas emissions. Fossil fuels are used for heating, lighting, and later for powering buildings, which creates an avalanche-like flow of greenhouse gases and pollutants. Thus, construction for an environmental-friendly closed loop has evolved into a dangerous pollutant and source of greenhouse gases. The impact of climate change on the construction industry is very important. There is a misconception that climate change is the smooth increase in the average annual temperature. After the planet is thrown out of balance, chaotic changes in the average annual temperature are observed with a large range and record low and high peaks. For example, from 2007 to 2012, the average annual temperature steadily declined. Then in 2013 it suddenly rose and remained stable until 2015. Then it suddenly rose to a record value, fell and continued its chaotic behavior. At the same time, the trend line for 22 years has been steadily rising. It's important to take significantly long time intervals here. For example, if we took the trend for 6 years from 2007 to 2012, we would see a catastrophic cooling, which doesn't correspond to a long-term pattern. Such a graph means the practical impossibility of predicting temperature change even for the near future. The lack of such a prediction for construction is worse than constant growth. After all, we can't estimate how many days the temperature is favorable for construction processes. Also, due to the increase in the amplitude of temperature fluctuations, it becomes practically impossible to assess energy needs and optimize the properties of buildings. An increase in temperature and relative humidity reduces the durability and worsens the properties of building materials. Fluctuations affect not only temperature, but also the precipitation regime. At the same time, frequent abnormally strong precipitation and winds are alternated by droughts. With heavy precipitation, especially with flooding of cities and winds, it's impossible to carry out external work, extract certain type of raw materials and supply materials, which leads to disruptions in construction deadlines and increased likelihood of construction debris being washed out into the environment. At the same time, with heat and droughts, the need of water supply of construction sites increases. Due to drying out of the soil, dust release stays stronger. Fire danger also increases. Significant fluctuations in cloudiness and winds make it impossible to provide a sufficiently accurate technical and economical justification for the use of solar and wind energy, as well as to take into account the actual efficiency of solar panels, which is strongly dependent on temperature. An increase in temperature reduces the efficiency of thermal power plants and heat engines, and this increases the embodied energy for the production and supply of all materials and products, as well as construction and installation work. The operation of construction site become unpredictable. Flooding lead to destruction of basements and ground floors. Recent events in Poland have shown the catastrophic consequences of flooding with the premature end of the life cycle of some buildings. This required additional construction work to demolish the building with the production of a sudden excess of waste. Nevertheless, even without flooding, operating buildings in an unstable climate leads to the risk of sudden energy bankruptcy due to record low high temperatures and a sharp increase in heating costs, which leads to debts for utility bills. However, on average, over decades, there is a decrease in energy consumption for heating and an increase in energy consumption for air conditioning, which can lead to the premature need to replace air conditioners with more powerful ones, a large expenditures and waste generations. Thus, climate change negatively affects all stages of the life cycle of buildings. Let us talk about the impact of construction industry on climate change. The negative impact of the construction industry on climate change is determined by energy consumption at all stages of the construction life cycle, from raw material extraction to building dismantling. This results in thermal pollution of the environment and greenhouse gas emissions from fuel combustion. In addition, construction leads to the displacement of natural landscapes capable of reflecting solar radiation and converting it into biomass. In contrast, building and road materials significantly absorb solar radiation and convert it into heat. However, the impact of the construction industry on climate change can be positive if carbon is stored in building materials, or in the future carbon-free greenhouse gases, although such technologies doesn't exist today. This technology has been used for a long time when using wood, which is a result of carbon sequestration. But this requires the use of wood that is constantly being renewed rather than deforestation. For this, fast-growing trees that can regenerate quickly as well as agricultural waste are promising. The use of concrete that intensively absorbs carbon dioxide is also promising thanks to the special additives. Another method is green structures, a combination of structures and living plants that sequester carbon. Let us conclude and summarize. The history of construction has come a long way from being environmentally friendly to one of the main drivers of climate change. Now construction and other industries are in a vicious circle where climate change negatively affects the industry and increases the burden on it, which increases the negative impact of the industry on climate change. Therefore, the transition, not a return to the past, of the construction industry to the concept of green construction and the circular economy is a condition for the survival of humanity. Thank you for your attention.